Well, next up, we have Simon Wardley. He's a researcher and advisor for the Leading Edge Forum, and he will be joining us live online today. Today, Simon will be talking about crossing the river by feeling the stones. Please join us in welcoming Simon.
Thank you ever so much. I've got to say, my preferred choice of word would obviously be excellent from Bill and Ted's Most Excellent Adventure. What I'm now going to do is share my screen. Hopefully you can see that. Crossing the river by feeling the stones. So I'm going to talk about a number of subjects today to do with the idea of strategy, maps, and also patterns that come from it, and their relevance to this whole world of Agile. Now, to start off, I better start at the beginning, which was 17 years ago. So 17 years ago, I worked for this company. It was called Fatango, online photo service. I had about 16 different lines of business, had adopted something called extreme programming in early 2000, very profitable, revenue growing, but it had a problem. The CEO was very good at adopting extreme programming, getting everybody to, bring their own technology, work from anywhere in the world. This is the sort of stuff we did in 2004. But the CEO was fairly clueless when it came to strategy. They had none. They were just making it up as they went along. And I know this because I was the CEO. We were very, very profitable, but, I would make up these wonderful vision statements, which were just words I'd copied from other companies and sort of rearranged orders. So I used to read everything I could find into the subject of strategy, and I was getting absolutely nowhere. And then I ended up in a bookshop in London, in Charing Cross, and the bookseller said, she asked me, had I ever read Sun Tzu's The Art of War? To which the answer was no. So she persuaded me to buy two different versions of this book. And because they're all translation, they're all subtly different. And I'm very grateful for this because it was in the reading of the second version, I noticed a particular pattern. So Sun Tzu talked about 5 things which mattered in competition. First of all, have a purpose, a moral imperative. 2, understand the landscape you're competing in. 3, understand the climatic patterns. So that's like the weather, the heavens, how the landscape is changing. Then understand doctrine, which is principles of organization. And finally, you're into leadership and gameplay. And this overlapped with something that the mad major John Boyd called the OODA loop. So the first O of the OODA loop, and this is used in US Air Force now in political circles, the first O is to observe the environment. So that's what landscape and climatic patterns are about, the landscape and how it's changing. The second O is to orientate yourself, and that's what principles, doctrine, are about. And then you need to decide where you're going to act, and then you act. And that's what leadership, and that's where gameplay comes into the equation. And of course, when you act, it might change the game. So you've got to observe things and go through the cycle all over again. Now, at the heart of this are 2 whys, the why of purpose and the why of movement. And they are very, very different things. So if you think about playing a game of chess, the why of purpose might be to win the game, or it might not be. You might want to lose the game or whatever. But the why of movement is, do I move this piece or do I move that piece? So we've got the why of purpose and the why of movement, and it's through movement and action we actually learn how to play the game, as long as we can perceive the environment. And this is what got me into the whole area of maps, because fundamentally landscape is the bedrock on which all the rest of this stuff is built. So I started reading everything I could find in military history about maps and the use of maps. And I went back to my organization and I asked everybody, send me all the maps you've got. And they sent me loads, business process maps, mind maps, things like systems maps. And this is a system map for one of the online photo services. As I said, it was one of 16 different lines of business. And I took one component, customer relationship management, and moved it across the map and asked, how has the map changed? And the answer is, it hasn't. Well, hang on. If I take a geographical map and I take, say, Australia, and I move it next to England, that really has changed that map. So why hasn't it changed here? Well, it's not a map, it's a graph. Everything we have in business which calls itself a map is almost always a graph. So just to explain the difference, these three images at the top are identical. They are all graphs, 3 places connected by 2 roads. And these 3 images at the bottom are all completely different, and they're all maps. The difference between a map and a graph is in a map, space has meaning, whereas in a graph, it's simply the fact that you've got 3 nodes connected by 2 links. Doesn't matter where you put them, they're still identically the same, whereas obviously in a map, it's different. And that's useful for exploring territorial landscapes as well as economic landscapes. Now, in order to create a map, you need 3 basic things. You need an anchor, such as magnetic north. You need the position of pieces relative to the anchor. So this is north, south, east, or west of that. And you need something known as consistency of movement. So if I'm going north, I'm going north. If I'm going south, I'm going south. So I started off by mapping my business, but a simple one to show you is mapping a tea shop. We'll start with an anchor. So we go public and business. Public wants a cup of tea. Hopefully the business wants to sell cups of tea. Right. Well, a cup of tea has needs. It needs a cup of tea. It needs hot water. A hot water has needs. It needs cold water. It needs a kettle. Kettle has needs. It needs power. So what we've got is an anchors at the top, public and business, and a chain of needs. And this chain of needs, the further you go down it, the less visible things become. So if you're a member of the public, the cup of tea is very visible, it's right there, but the power to use to heat the kettle, that's quite far removed. Still important, but it's far removed. So now what we've got is anchor and position described through visibility. Now it turns out that all of these components are forms of capital, and they evolve through a common pattern. We start off with the genesis of the novel and new, custom-built examples, products and rental services, and commodity and utility services. So I can take whatever it is, and I simply go, right, how evolved is this component? Now what I've got is anchor, position, and movement described through evolution. And if I now move any piece on that map, it changes the fundamental meaning of what the map is. But the map is also exposing my assumptions around a space, and that becomes really important. So explain why. This is an insurance company, 2011. This is a process flow. It's a graph for them getting compute into their data centers. They realized they had a bottleneck. So they would order a server would come into goods in. They had a bottleneck about racking the servers. So they came up with a plan to invest in robotics. It was many millions. They spent about 6 months working on this. They're about to go ahead. Wonderful business case, all the return on investment calculations, all the sensible sort of stuff you would expect to see. And they asked me, what did I think to the plan? Well, I can't just go in and challenge why are you building robots, because they built an entire narrative, a story about why robots are important. And if you go in there and you challenge, well, the problem is we have an entire industry which tells everyone that to be a successful leader, you've got to be a great storyteller. So when you tell somebody their story isn't right, you're actually saying to them, you're not a great leader. And they get very defensive about this. So I can't just go, why are you using robots? So I asked, could you map it? Lots of, oh, we're not sure about that. It took them 15 minutes. They went, user needs compute, order server, server goods in. And they went rack, mount, modify. Now, I can look at this map and I can go, I think there's something wrong with the map. I'm not challenging them. I'm just talking about the map. And so I simply said, why have you got racking custom built? And it turns out that they had custom built racks. So what are the modifications you're making to servers? Well, the servers they bought didn't fit their racks, so they had to take cases off, drill new holes, add new plates to get them to fit our racks. And that's why you need robotics. Yes. So, a few minutes later, somebody in the room simply went, why aren't we using standard racks? Well, the reason why they weren't using standard racks is not because these people were daft. It's because at some point in the past, that made sense. And they were simply trapped by narrative, trapped by the stories they had told themselves. So it became very simple. What they've been trying to do is optimize process flow, and that would get you going out and spending millions on robots. Or in this case, they realized this component had evolved. And therefore, we just need to use standard racks. Of course, once they made that jump, they realized that compute was more of a utility. It was 2011, 2012. It was already a utility by then, so that it was quite easy for them to go, we should be using cloud. Now, this is one of the most common problems that I see. People optimizing things like process flow rather than evolutionary flow because they can't see their environment. We've used a lot of this stuff in government in the past. One project alone, we saved about 425 million just simply by mapping it. And of course, these days maps are used all the way up into space. I mean, the Carbon Mapper satellite, which was produced with NASA, working with Planet and others, they use maps in the background to work between them, these forms of maps that I'm showing you. But one of my favorite examples comes from heavy engineering. So this is HS2, high-speed rail, and this is James Finley, former CIO. And back in 2011, they had a problem. They had a problem in the fact that they were going to build this railway, and it's a big, expensive project, and they didn't want to get it wrong. So James thought we'll build the entire railway, first of all, in a virtual world. Because if you dig up a virtual world and go, whoops, we've got that wrong, it's much cheaper than digging up the countryside. So this is the systems graph for building HS2 in a virtual world. Now, normally in government at that time, what we tended to do was outsource all these components to other suppliers, and we often group them together into what we call logical structures or lots. So we'd have lot one engineering. There's a whole bunch of engineering sounding things. We'll put that in that contract. Lot two user experience, sort of user experiencey stuff. We'll put that in that contract. Lot three back office, lot four infrastructure. Now, these projects had a track record of being a disaster, massive cost overruns, etc. So James, what he did was he sat down a Sunday afternoon and he simply mapped it out. And that's the map. He sent that to me and asked, how do you manage something like this? It's pretty straightforward. I took the map, tidied up a few little bits, and then pointed out that as things evolve across the map, they change in their characteristics. So they start off on the left-hand side in what we call the uncharted space. And it's highly uncertain, very chaotic, constantly changing. And that over time, they become more industrialized. So you've got lots of the unknown on the left-hand side, more industrialized, more defined on the right. Now, because of this, back in 2006, we'd learned that different methods were suited to different spaces. So, for example, extreme programming was truly fantastic on the left-hand side, because it's all about reducing the cost of change, and change is the norm. So if change is the norm, what you want to do is reduce the cost. But on the right-hand side of the map, things like Six Sigma, outsourcing, extremely strong, because they reduce deviation. And in fact, you don't want deviation from an industrialized commodity. You want to reduce that. And in the middle, more lean methods, so things like Scrum, MVP are better there, because you're all focused on learning and reducing waste, which is what you want to do. We've gone from this world of change, we're heading to this world of becoming a standard commodity. We've got to learn, we've got to reduce waste. So we simply take that and apply that to the map. So on the left-hand side, we used extreme programming, in-house development. In the middle, off-the-shelf products, or if we're building ourselves much more lean, so you're using Scrum MVP. Right-hand side, we're using outsourcing to utility providers. We're using much more approaches like Six Sigma. Very simple. Now, this project ended up in front of the Public Accounts Committee because it was delivered way ahead of schedule, way under budget, which was pretty unusual at that time for a government project. Now, the first thing I want to note with the map is there is a world of difference between using Agile, such as using extreme programming, and being Agile. Being Agile requires you to use appropriate methods. I.e., if something is industrialized, you use things like outsourcing or utility providers ideally, or use something like Six Sigma if you're building. You don't use extreme programming for the more industrialized. Likewise, if you're learning things like Scrum MVP, starting on that sort of basis are the best approaches to take. So being Agile requires you to use appropriate methods. Using Agile is just like using extreme programming where appropriate. And the reason why I want to emphasize that is if you decide to outsource the whole lot, and or use something like Six Sigma across the whole lot, it won't work very well. And the same as if you try and Agile the whole lot, use extreme programming across the whole lot, it won't work very well either, because those methods have developed to be very good at one thing, which is reducing the cost of change, or another thing, which is learning, reducing waste, or another thing, which is reducing deviation. They're not the same. And let's go back to the original systems graph. Let's take one of the lot structures, engineering. I'm just going to take that contract and overlay it onto the map. I can tell you this contract is flawed before we've even started, before we've even signed the paperwork, and it's going to fail. And the reason why it's going to fail is some of the parts in the contract will be efficiently treated because we can specify them, because they're quite industrialized, well-known and defined. But the other parts, we don't really know what they are. So they're always going to change. And so if you've specified them in a contract, you will always incur excessive change control cost. Now, those are the basic, most companies, they're very poor at understanding the users, the user needs, the actual components of the supply chain, how evolved those components are. That's the basics of mapping. And then, of course, once you've got that, you can allow people to challenge. Why are we using robots or custom-built racks, for example? Focusing too much on process flow rather than evolutionary flow, that's another huge waste that companies do. And then you get into the one-size-fits-all magic method. There isn't one. You've got to learn to use multiple methods, a world of difference between using Agile and being Agile. And lastly, most contract structures that you see in corporations are fundamentally flawed as well. When you break them down, look at them in context, they've often bundled these things together in ways they shouldn't have done. All right, so that brings me quickly on to patterns. So one of the things about mapping is we use mapping for pre-mortem challenge. So this is the bit where we map out a space and discuss what we're doing. Is the map right or wrong? Can we improve the map? Then we go build something. And then afterwards, we use the map again for post-mortem learning. So what happened? How does that compare to what we thought on the map? And that's how we learn patterns. Now, there's three basic types of patterns: climatic, doctrine, and leadership. I'm just going to explain climatic and leadership very quickly. We'll skip the doctrine. All right. Climatic patterns are the rules that influence the game. You don't get a choice about them. They happen all the time if there is supply and demand competition, but they're useful for anticipation of change. So this is a basic map of compute in 2006. A user needs an application built on best coding practice on a runtime. That's an area in which you code, like lamp.net. Built on an operating system, built on best architectural practice for compute as a product. So this is things like scale up, capacity planning, disaster recovery test. So this was 2006. During 2006, compute moved from being a product to more of a utility. with the introduction of Amazon AWS EC2. So the first pattern you learn with mapping is everything evolves. If there is supply and demand competition, it all moves from the left to the right. The next pattern you learn is we have inertia to this change because of pre-existing capital. So if I had lots of best architectural practices around disaster recovery test and capacity planning and big data centers with lots of servers, I had huge amounts of resistance to this shift to the cloud in 2006, 7, 8. The next pattern you learn is that as things evolve, their characteristics change, and that causes a new set of practices to appear. And this is known as coevolution. So you start off with best architectural practice for compute as a product, which is like disaster recovery, capacity planning, and it's based upon the characteristic of what's known as high MTTR, high mean time to recovery. It takes weeks to get a new machine if your machine goes bang. But now in the cloud, it takes seconds. So now we can distribute systems, design for failure, we can do continuous deployment, and eventually those practices got a new name. We call them DevOps. The next pattern you learn is as things evolve, they enable higher order systems to appear. So it's easier to build interesting houses with standardized bricks. So anything which becomes more industrialized enables the new to appear. That new is what we call the adjacent unexplored. We don't quite know what's going to appear, what people will use compute as a utility for, but we know exciting stuff will appear. The next pattern you learn is out of that exciting stuff, new sources of value will be created. Oh, look, somebody's doing video streaming, Netflix, whoever it happens to be. Okay. Now, back in 2008, I used to run strategy for a company called Canonical. So we used the map to work out where to invest. Basically, we knew in 2008 that everything was going to the cloud. You have no choice about this because it gives you efficiency. The new practices give you speed. The new needs give you new value. And if you're in competition with others and you've evolved and you've got efficiency, speed, new value, you create pressure on everyone else. And as more evolve, the pressure mounts until everybody has to evolve. And that's known as the Red Queen effect. So we knew the future was cloud. We knew there'd be emerging practice. We didn't know it was going to be called DevOps, a term created by two friends of mine, Andy and Patrick. We knew there would be new needs. So that's where to invest, and where to run away from was data centers, servers, and all those old architectural practices. So that was 2008. We were up against, we provided something called Ubuntu. It's an operating system. We were up against Red Hat and Microsoft, big giants. It took me 18 months. We had £500,000 to spend. We were 2 to 3% of the market. By the end of it, we were 70% of all cloud computing. And it was very simple because, we were competing against people who didn't understand the landscape, couldn't see the map. We knew exactly where to target. Of course, those emerging practices continue to evolve. Eventually, we gave them a name, DevOps. The best architectural practices, we gave a new name to. We called them Legacy. And then in 2014, the runtime started to shift from product to utility. So we went from LAMP.NET to much more AWS Lambda, what we call serverless, and exactly the same patterns appear. So it's all about now efficiency, new emerging practices. So that's called FinOps, and the new things being built. And why that matters is you learn the pattern that strategy is iterative. So everything we used to think was important in 2008, moving to infrastructure as a service, these new practices like DevOps, they're all heading towards the new legacy. Today, and certainly in 2022, you should be focused on building with serverless, looking at those emerging practices, which are all to do with things like capital flow. There's a wonderful book coming out called The Flywheel Effect, written by Dave Anderson and others. And this discusses the journey of Liberty Mutual as a 100-year-old insurance company to that sort of serverless world. I mean, if your company is embarking on containers, Kubernetes, and DevOps, it took my friends Netflix about 7 years to get rid of their data centers. You won't be any quicker. By the time you've built it, you've just built the new legacy. So please don't. think about serverless. All right, doctrine are principles of organization, things like focusing on user needs, understanding the components, challenging assumptions. There's about 40 of those. There's about 30 climatic patterns useful for anticipation. We won't go through that. There's over 100 different forms of gameplay. Again, most people are oblivious to this stuff, and I'll mention just one to you. It's called innovate, leverage, commoditize. It's very simple. Take a product, you turn it into a utility. Then what you do is you get everybody to build on top by exposing it as an API. For example, we'll take compute, we'll turn it into a utility. Let's give it a name. Let's call it, I don't know, EC2. Everybody builds on top. Now you have to build them because they're consuming your service. And that metadata you can use to spot what's becoming interesting. So if everybody's building kitten internet and a couple of people building big data and you see the big data bills going up, there's something interesting in big data. So use the ecosystem to spot future patterns, which you commoditize to new component services. Let's give it a name. Let's call it, I don't know, Elastic Map Reduce. Now, what happens? Everybody you've just eaten their business goes, oh, you've eaten my business. Everybody else cheers because they can now build things more quickly. This model, what you're doing is you're getting everybody else to innovate for you. Everybody building on top is your free research and development department. You're mining metadata to spot future patterns, and primarily you're focused on commoditizing components. And as a result of this, your apparent rate of innovation, customer focus, and efficiency will all increase with the size of the ecosystem. So the bigger the ecosystem gets, the more innovative, customer focused, and efficient you will be, which is a devastating compliment. Now, I wrote about this back in 2005, and you see it today in companies. You use it on the right-hand side of the map. We'll industrialize compute as a utility, then we'll go into machine learning engines, then platforms. Now we'll start providing discrete services for vision, chat, etc. And it's not just companies, Chinese government, spectacularly good at this sort of gameplay. If you want to read more about that, AWS, I think it's their second ever book themselves, published a book called Reaching Cloud Velocity. You'll find 17 pages of mapping in there, including the whole ILC model. You can use this just to chew up industries quite effectively. All right, so I started off with the strategy. So I used to run this photo company, 16 different lines of business. We were doing lots of exciting things, but I hadn't got a clue actually about strategy. I read every book I could find. None of it made sense to me. And so mostly I was just using words as a substitute, listening to whatever the most popular meme was. If you were doing it today, you'd go, well, we've got to AI stuff. We've got to agile everything. We've got to, you'd probably say DevOps things as well. It's whatever the popular meme is. That's exactly what I used to do. Roughly 2005, so 17 years ago, I started to realize the importance of actual maps, actually understanding your competitive environment. And it's important whether we're dealing with an individual project or a company, or most of my stuff is like nation state competition. Now, maps are imperfect representations of a space. They all are, even geographical maps. If you want a perfect map of France, it would have to be 1-to-1 scale, which means it would be the size of France and therefore not much use as a map. So all maps are imperfect representations. But once you have those, then people can start to challenge and question why we're doing things, which enables us then to look at what changes and start to learn patterns, such as climatic patterns, useful for anticipation. Doctrine and principles, useful for organization, but that's a topic for another day, and also things like gameplay as well. So at that point, I will just leave you with a message of crossing the river by feeling the stones, Deng Xiaoping. It's all about sort of having an idea, a purpose of where you want to go, and understanding the landscape as you move along. Thank you. Now, I don't know if there's any questions, but I know we started late, and I know you've probably got a busy agenda, so you might want to end at this point. But I'm happy to answer questions if anyone's got a dying question to ask me.
Did we have any questions?
Total stunned silence. Can I ask, can you wave your hands if you use mapping at all? There's a couple of you. Good. Do you want to shout out what your experiences has been, including the negative? I love the negative stories as well as, because I get all the positive, and people are a little bit shy about telling me they're negative, but they're important as well, the constraints and limitations of the system. So tell us how you've got along. How did you come to mapping, and how have you found it?
So I've got a question.
Yes.
When you move compute over to the cloud,
Yeah.
aren't the problems that were previously done by you simply then just part of the vendor's problems?
Oh, absolutely. So when we go back to this, let's have a look. I'm going to flip back various maps. Right. We'll take it from that one. When we talk about something like compute started Genesis 1943 Z3, custom-built systems like Leo, Lions Electronic Office, and then you get into the first products like the IBM 650, constant improvement of products, and eventually you get 2006, it starts to become a utility. It's all compute. The difference being is that, at the beginning, everything was much more custom built. Then we started getting into products. And now, if I want 1 million servers, it's API calls. It's all identical. So it's highly industrialized, high levels of commoditization. So all that, so what's happened is that thing has now evolved to becoming a more of a utility. And because of that change of characteristics, it allows an entire new set of practices to emerge. And those practices are what give us speed. So, we're no longer having to worry about machines being delivered. We're now distributing systems, design failure, chaos engines, etc. And a lot of the stuff that we used to worry about, like spending our time worrying about racking servers, worrying about, fitting in network cables, worrying about power supplies, worrying about air conditioning units, worrying about the physical security of the building, that sort of stuff is all gone. And that sort of stuff, is wrapped up in the actual pricing that we're charged. So it's quite interesting. I often get people say, oh, we should build our own cloud. I had a particular bank, well, lots of them actually, and this particular bank said, oh, we can do it cheaper than Amazon. And I sat down with them, I said, really, show me. And so they came up with their spreadsheet, their figures and everything else. And I simply asked, how much is the electricity? And they went, oh, that's another budget. Right. Well, electricity is about 40% of the cost. Okay. And you've said that's another budget. And so we just added up all the other budgets. And basically all they were doing was looking at hardware and software, which is actually about 20% of your cost. The other 80% is everything from electricity to security, physical buildings, all this sort of stuff. And so they were ignoring most of the cost in order to justify continuing to hold on to their data centers. I mean, you see some of this today with, so one of the things about COVID and the isolation economy acted as a forcing function for something that was already occurring. So space was already moving from sort of like the product to the physical world to more industrialized, which is what you see with the virtual space. If I want 1 million shops identical, it's an API call. Simple. I mean, in the physical space, I can't do that. It's much more product because even custom. And of course, as a result of which you get that change of practice. So we built lots of social practices like collaboration, cooperation, innovation, how we work together, socialization, everything associated with the physical space. And of course, as it evolves to more of a utility, which is what virtual spaces simply represent the industrialization of space. You're going to have to redevelop those practices. And of course, some people were not familiar, how to do this. And of course, a lot of people had a lot of trappings from the physical world, which they couldn't bring in to the virtual world. And the typical example of this are things like power structures, such as, the top floor office. What is, you spend all this money on having a top floor office to say, I'm an executive, aren't I important? You're all on a Zoom call. Where's that gone? Where's my private car parking space? Emphasizing to everybody how important I am. That's just disappeared and so there weren't the same sort of status symbols, which is why there's been a desperate attempt by so many people to get back into the office. It's not because of reasons of productivity, what's good for the organization, etc. A lot of it's wrapped up into inertia, like I've just spent a load of money on this very expensive building. What do you mean we don't need it anymore and it should be a vertical farm? I mean, what about my status symbols? What about my who's going to believe I'm an executive if I don't have a top floor office and a little badge saying CEO or something along those lines? That's so you saw exactly the same sort of inertia and problems as we shifted to cloud 2006 to 2008, and you're seeing it with serverless today. It's quite amazing number of people run around saying, it's got to be Kubernetes and containers and things like this, and it's just like, fine. Great. Well, we'll see you in about 10 years' time when you now realize you've just gone down the wrong path.
Oh, thank you, Simon. We appreciate you joining us
Pleasure.
virtually.
Sorry about that.
A round of applause for Simon Wardley.
Take care. Look after yourselves.